Hello everyone, welcome to my channel Tipsora Pod. If you are just tuning in, please like, subscribe, hit the bell icon so you get notified when I release new videos. If you have any questions and feedback, discuss in comment or you can direct message me. This video, I'm going to talk about the Microsoft Fabric overview. I know Microsoft Fabric has been around for a while. In future, I'm going to deep dive into specific features of Fabric or how to do specific things. In this video, I'm going to do a high-level walkthrough of all the features and what's the thought process behind Microsoft Fabric, what are the different components, and what can you do in each of those components within Microsoft Fabric, so that this video is kind of going to form the baseline of future detailed videos that I'm going to do. Okay, so let's talk about the Microsoft Fabric overview. I'm going to go through the thought process of what got Microsoft Fabric created, right? So, AI is now everywhere. AI has become more practical than ever before. Every company is now rushing to figure out how to effectively use AI to gain competitive edge. With that, CIOs everywhere are figuring out how to effectively build their data estate to get their data ready for AI. But the challenge is that there are just too many data products in the market, and to integrate all those products together to build an overall strategy and have a high level product is challenging. Now, what ends up happening is that people use all these different products and then they spend more time integrating those products than actually building that data and AI strategy. And each of these products, they come with different vendors, so sometimes support might be challenging. That one vendor is saying, our issue, it's not our issue, it's that product issue. So you kind of spend more time going back and forth than getting your work moving, right? And if you are using cloud or multi-cloud, then you have some stuff on-prem, then you have something in the cloud. So making that integration, that creates another layer of complexity in integration, right? One way to keep it simple is, if you just use Azure and use all the native Azure services, the integration kind of becomes simpler. But still, if you're using PaaS services, there are just too many knobs to control. It still requires a deep technical expertise to make everything work optimally without any issues. You still need multiple teams to kind of manage all these different services, and sometimes that can lead to data silos where you have all these different teams where they all use their own tech stack, and there is not much communication between them. So that will lead to uh, having data duplicated, and all these different tech stacks using the data differently, where it becomes challenging for the CIOs, the top business leaders, to have an effective strategy that is implementable across the company, right? So this is what the CIOs everywhere are saying, that we want to be the chief information officer, not the chief integration officer. So we want to be able to understand what information we have and how to effectively use it. We don't want to be spending too much time integrating these services, right? So that's kind of what gave birth to Microsoft Fabric, because Microsoft Fabric takes from PaaS to SaaS. So, instead of having all these individual platform as service component that does pieces of your analytics, Microsoft Fabric does end-to-end analytics, starting from ingestion, data engineering, data warehousing, data science, your event-driven programming on your data, to BI and data visualization. Everything is comprehensive in a software as service, a SaaS application. So you just log into Fabric and everything is ready, already deployed. You don't need to provision anything. You can just start using it. So your component becomes a unified stack. Your single database becomes your entire data estate. And instead of isolated applications, you have a fully comprehensive application, and you are ready to start building your Gen AI application. Okay, so this is kind of high level architecture of Microsoft Fabric. There is Data Factory, which is the ingestion part of Fabric that you use to ingest data. Then there is Synapse Data Engineering, which you can use to create features, massage your data the way you want to be ready for your analytics. You have Synapse Data Science for building machine learning and AI, Synapse Data Warehouse for those traditional, warehouse reporting type of application. Then you have Synapse Real Time Analytics for building real time queue or streaming type of data analysis. The Power BI for your BI and data visualization. Then there is Data Activator for building that event driven application, where when this change happens to the data, you react in this way. And all of this lives on a single data estate called OneLake. So OneLake is a comprehensive data lake which encompasses your data lake as well as your data warehouse. So everything is stored in one place, and the data is governed by Microsoft Purview, so which offers you the data lineage and data classification. So that's the overview of Microsoft Fabric. And now I will go into the portal and show you what it looks like. Okay, so before I show you Fabric, I just wanted to let you know that there is a new Microsoft certification available on of Microsoft Fabric called Microsoft Certified Fabric Analytics Engineer Associate. Yes, and this kind of describes what that certification is, what type of topics are covered in that certification. On this page, you have a learning path, that you can do to kind of learn and refresh your knowledge on Microsoft Fabric. The exam is called DP 600. You can take that exam to get the certification. If you watch this video, most of the stuff I talk about in the video is taken from these tutorials. So if you don't want to go through this and do build everything on your own, or maybe you don't want to use your own Azure subscription, you can just watch this video, and that will give you enough information that you could probably just watch this video and go take the test. But I would still recommend going through this learning path and getting some hands on, get some muscle memory that will help you understand things better. Now, if you have Fabric, the way you know whether you have Fabric or not is you go to fabric.microsoft.com, and you know if you do that, it might ask you to sign in. I'm already signed in, so it just opens up. But if you go to fabric.microsoft.com and it's not loading for you, that means either your admin has not enabled Fabric in the tenant, or you don't have the license to it, or they just have not added you into Fabric and they haven't assigned the license to you. The way, if you are the admin, you could go into the admin portal, and there is this tenant setting, and within tenant setting, these Microsoft Fabric needs to be enabled. Okay, so, and there is a user level setting, so this needs to be enabled, and there are different workspace level settings that admins can change. So if you are not able to do something on Fabric, talk to your admin. They need to go through these settings to make sure you are set up right for you to use. Within the admin, you also get like, you know, usage metrics of what's being used. You get different user. So, you know, on Microsoft 365 Admin Center, you assign the user, and then here you can assign license per user. There are audit logs, domain settings. You know, these are, you know, for large enterprises, they need to be set. There is capacity setting, which basically tells you the license that you have, right? So I am on a trial, so it tells you that I'm on the trial capacity, but this is where you can change your capacity if you wanted. You get embed code if you want to embed any component of, you know, Fabric into the web, like the Power BI embedded. You get organization wide visuals. You can, you know, you can have your own Azure connections that you can get from here. Workspace level settings are here. You know, you can add your own image. You can change the theme color if you want your Fabric to look according to your corporate theme. There are some protection metrics. You can enable, you know, some tenant level security. You can enable, you know, Microsoft Defender. uh, and there are, you know, some featured content that you want your organization to know. You can add those here, right? So if you are admin, you know, you need to go through this. But you should be, regardless of whether you're admin or not, you should be aware that all these settings are there. So if you're having some challenge with doing something, more than likely you are not set up for it. So contact your admin. Now, first thing, I talked about Microsoft Fabric OneLake. So when you have Fabric set up, the first thing you need to set up is workspace, right? So if you go into workspace, you say create new workspace and give it a name. You can add an image if you want. I already created a workspace called my workspace. So your workspace kind of contains everything, right? And within, like, you also have a way to kind of create a domain, and then within domain you can group multiple workspaces. But that's, you know, for big organizations, you need to do those groupings to create data mart architecture. If you want to have your different departments have a different level of control and you want to manage their costs, so for that, there is, you know, you can structure your workspaces according to domain, so that you have some control at the domain level, then you have some control at workspace level. So you can organize those that way. For the purpose of, you know, this video, this is a first high level overview. I won't go into details of those. I do want to show you that within the OneLake, when you click on the OneLake data hub, you see all your artifact, right? You see what database, data warehouse you have. And here, if you are the admin, you have the option to do an endorsement. So when you endorse, you have the option to, like, say promoted or certified, right? So when you do that, it's like it's your way of saying that, you know, you recommend this data set to be used by others. So that's how, if you do that, when people log in, they're going to see it here, that, oh, this is promoted by my company, this is certified by my company, this data is ready to use. That's how people are going to discover data better. Another thing about, you know, OneLake for Data Hub, I said, you know, that OneLake is kind of like OneDrive for your organization data. There is a software called OneLake File Explorer. Okay, so you can download this file, right? So if you download this, you get this download page, and there is this one lake plus, it's an msix file. If you install it, then it will install, and it will make your OneLake appear within your folder structure, just like OneDrive does. And you can now browse your OneLake from within your Windows File Explorer, the way you explore your OneDrive. So I can go into my Lakehouse, I can see my tables and files, everything, right? just like I browse my OneDrive. So that's why OneLake is called the OneDrive for your organization's data. Okay. Now, the next thing I wanted to show is once you have Fabric, remember Fabric is your ingestion, data engineering, your data science, your real-time analytics, and event-driven programming all rolled into one. So because of that, it has these different views or different personas, right? So you might have some data engineer and you only want to give them access to the data engineering part of Fabric, or maybe you have some BI developer, you only want to give them the Power BI side of Fabric, right? So and depending on what they have access to, they get these different persona, right? So you can go to Power BI mode and you only see the Power BI stuff. Okay, you can go to the data factory and you see your data engineering, the data factory side of things, right? You go into the data activator, then you see your reflex, the event driven programming side of things. If you go into data engineering, then you see your Lakehouse, pipeline, notebook, and your Spark, right? If you go into data science, then you see your machine learning model, your ML experiment notebook, right? If you go to real-time analytics, then you see your KQL database, event stream. We'll go through all of these, but I just wanted to show you that those personas are here. There is a monitoring hub, so you can monitor all of your different artifacts, how they are getting used, which pipeline succeeded, failed, all those you kind of see within your monitoring hub. And there are metrics that you can see from within your monitoring. Okay, now in the next we are going to look at the data factory side of Microsoft Fabric. As you can see, I have set my persona to Data Factory, and within Data Factory, we have Data Flow Gen 2 and Data Pipeline. So, Data Flow Gen 2 is the Gen 2 of what used to be the data flow in Power BI. Okay, so the best of like data flow from Power BI and the mapping data flow has been taken into creating the Data Flow Gen 2. Okay, so the data flow gen 2 is what you use to create data transformation using UI, like the Power BI type of data flow. You can use data flow and say give it a name, and it pops up this Power Query interface where it gives you different ways to get the data, right? For example, if you have a file downloaded, you can upload it here. So as you can see, since it's kind of expecting you to upload from local, so that means it's expecting the data size to be something that you have on your machine. So the data flow gen 2 is not recommended for very high volume data. It's kind of a mid-range size of data. The UI features are very nice for a citizen developers to kind of do data manipulation. But if you have very large data, it's probably better to use the notebook interface, where you have to write code, but the notebook, without the UI, can handle more volume of data than the data flow gen 2. Another thing is the data flow gen 2 is only uh, a data transformation tool. So this is what you use to, after you get the data, change, or create a new column using some of the other columns. That's what data flow gen 2 is for, right? It's not, it doesn't actually do the data movement. You need data pipeline to actually do the data movement. So the data flow gen 2 you use for data transformation, data pipeline is what you use for moving the data. So if in a typical ETL scenario, you extract, load, and then transform, right? So the extract part of it, you can do using Dataflow Gen 2. You can load and transform, but the actual, taking the data from one place to moving the data one place, that's when you have to kind of integrate your Dataflow Gen 2 into data pipeline to do that data movement. So you can, if you have the file downloaded, you can upload it here. Here is the data that I am uploading. Okay. So as you can see, it's a typical CSV file with first row containing the header. So if I go into my Dataflow Gen 2, once I have loaded it opens in this Power Query interface. Okay. And it has these different view. Right now I am in the data view. Okay. You have the option to see the actual Power Query. You can make it off, so it will disappear. You can go into the query script, so it will show you the entire script that was used to generate this. So if you wanted, if you are a Power Query user and you are very good with code, you could just take this code and add it to recreate this, or you can do any kind of transformation in the code instead of using the UI. If you are a citizen developer who is not comfortable with code, you can use the UI, but it's nice that it gives you the code interface and the UI interface at the same time, so that as you make changes, you can see in the code exactly what it's doing. So once I load that CSV, I basically said that I want my first row as header, so it detected these headers, and I can go into in any one of these, and I can change the data type, right? I can set data type here. I can create a new custom column, and I use some of the existing fields to create a add a new formula to create a new column. For example, my month number is a column that I created, where if I go into my step query, you can see that this column number is created using the order date, using the month of the order date function to get the month number out of the order date, and that's what appears here, right? And this is of type integer, and it's derived from a date field. So you can see in the formula how this column was created. So even though I created it using the UI, you can see the formula for what was used to create this. So sometimes you might not be the one who created it. You might inherit something. You might look at, okay, there is this column. How is this column created? This script field is going to tell you exactly how it was created. Okay. So you also have your diagram view, and you have your data view, right? And you have your schema view, so you can see what are the data types of each, right? So when I select the diagram view, it gives me this visual a representation of how what transformation has happened so far. So I got a source file, which is a CSV. I promoted the first row as header. I added a column as a numeric field, which is my month number, and that column was added. So all that transformation history is captured as a diagram, and you can add the full script to kind of see the whole change as a script. And you have your data view here, so you can see the data. So if you don't want that, you want more real estate, you could hide that. You could turn off the query so you get more real estate, so you look at your data. Okay. So that's how the data flow gen 2 works. There are many different functions, menus here. I'm not going to go into each of these for this high level overview. If you're familiar with Power BI, you probably already know this, but in a later video, I might deep dive into some of these for any particular problem that we solve. So we saw how to create data transformation using Dataflow Gen 2. Once you do the transformation in Dataflow Gen 2 using Power Query or using the UI, you have to publish it for it to be saved into your workspace. And then you have to add it to a pipeline to actually execute the data transfer, right? So for that, you need to create a pipeline. Okay. So let's now look at pipeline. Okay. So when you create a pipeline, you give pipeline a name, you click create, right? So then it loads a UI for creating your data pipeline, right? So in the pipeline, you have a copy data activity. You have, there are different activities that you can add. Most typical, like if you go into add activity, so you have these like copy data, data flow, delete, right? So you can add data flow into your pipeline, right? So if you add that data flow activity down within setting, you can select your workspace, and then you can select, for example, I created that orders data flow. I can now select my data flow here, so that my data flow that I put in my canvas is referring to that data flow, right? Now in pipeline, you can add multiple component, right? You can have for example, a copy data activity, right? You can add a copy data activity where your copy data activity can take from like I have something in GitHub. So if you look at this, now I have a GitHub connection, I have the URL for it, right? So you can use, as long as it's a public URL, you can use that connection to add that data as a data source, right? Or if I click new, you can see that there are all these different options available, right? Within file, you have, FTP, SFTP. So there are all these different ways that you can select your source file. You can select a destination file. In this case, I selected my lake house as a destination, right? Uh, so a copy data is a simple thing that you might use to just move data from one place to another, right? You can also, for example, add a now there is something called delete data, right? So maybe you are making sure the data in a folder is deleted before you copy the data, and then you want to do transformation, right? So you have it's important for you that you do it in this order. First you want to delete the data to make sure the folder is empty, then you want to copy it to a folder, then you want to do some transformation. So for that, you can have this delete data, and notice there are these pins that kind of notify how to connect. So the first one, it says, is on skip, right? The second one, it says on success, then on fail, and then on completion. So if you want something to happen after the delete data completed, you drag that delete data completed to your copy data activity, right? So your copy data activity will execute after your delete is completed. And similarly, once the copy is completed, then you want to make sure your data transformation happens, right? Okay, so here is a completed pipeline with all the components already loaded. So you can see I have a delete activity first. So I have a lake house called Sales Lake House. We'll talk about Lake House later, but since I already used it here, I'm just showing you that in Lakehouse you have tables and files. So within the files, I have a folder called new data, right? So in my pipeline, I have an empty sales data pipeline, which is a delete activity. So what it's doing is within the Lakehouse, it's deleting all the CSV files within the folder new data. So once the delete is succeeded, then the copy starts. So the copy is, taking that cell CSV file from GitHub over HTTP, and it's putting it into my sales new data folder as sales.csv. Once it's done copying, and this is completed, next I run a notebook. Now this is the notebook. In the notebook, I have hard coded the table name as pipeline underscore sales. And what I'm doing is I'm reading all the CSV files from there. And then, I'm adding the month column. I'm doing, I'm doing some derive out of the first name. So I'm making some small, data engineering here. Finally, I'm creating a delta table, and I'm appending the data into that delta table. So when I run this pipeline, all of these will be executed together. Now, I do want to show you that when you uh, run this pipeline, okay, so under run, you have the option to run it as is. Okay, you can save and run, which will, you know uh, show you the activity line by line, and they would be queued, and they would run. And while the pipeline is running, you can see some of its activities, like what it's doing through some of these outputs. So you get some debug trace type of information here. If you get an error message or something, also you would see the logs here. Finally, the notebook is running. That's in progress. Let's wait for it to complete. Okay, so everything succeeded. Now I want to show you that, when you run it, you can also run it with a parameter. For example, in my notebook, I hard coded the table name, right? So instead of doing that, I could use a parameter called table name here and give it a name. And in my code, I could use the parameter instead of hard coding, so that my pipeline becomes configurable, and I'm allowed to change the name before running, right? So that concludes pipeline. Okay, since we talked about Lakehouse in the last data pipeline example, let's now look at how to create Lakehouse. So I'm in my data engineering persona. So if I click Lakehouse, I just have to give it a name and click create to create a Lakehouse. Now I have already created a Lakehouse named Sales Lakehouse. So once you create it, you get like a table and files, right? So within files, you can create a new subfolder, you can upload files. There is also something called new shortcut. Now shortcut, if you're familiar with the concept of external table or polybase in Synapse, um, shortcut is similar concept where your data lives in another storage space. It could be Azure ADLS, it could be Amazon S3, or somewhere else, right? But with shortcut, your data will live where it is, but you would get a connection to it within Microsoft Fabric. So it's a data virtualization concept where it looks like, the table or whatever you created, your data in a different storage area is available to you as a delta table, even though it's not there, but it would look like it's there. So you can use it as if it's a local table, even though the storage is external. Okay. When you create these folders, you can upload files or you can write to these files any way you want, right? Now, if I have data like, sales CSV, I could, like, say, load to table directly from here, right? When I load to table, I can use comma separator. I can use this to kind of create a delta table out of my file if I wanted, right? So some of these files are created that way. So they're all delta table in Lakehouse, in Microsoft Fabric. All the tables are built on Delta, right? So Delta is the format in which the files are stored, that's used to create the table. The advantage of Delta format is that Delta is based on Parquet. For example, I created this sales table out of that CSV file. So if you look under the hood, the files for this are, see, there is a Parquet file and there is something called delta log, right? So a delta is nothing but this Parquet file as well as the delta log, and the delta log is a JSON file. So this JSON file in delta log maintains the transaction or the change log for that table. This is what makes the delta table, even though it's a Parquet file, appear like a database table, because it now supports transaction, because uh, all the transaction logs are captured in this delta log. So just like you have transaction logs in a SQL table, you have delta log in a Lakehouse table, right? So because of that, it can now support transaction. It can support rollback. It maintains the time history of all the changes that happen to the table, right? So, and you can see there is this little triangle on this table, so that's kind of signifies that they are delta tables. Okay. So now let's, so you can create a delta table by running a wizard, just using any file. You can just say load to table to create table, or you can create it in code, right? So let's look at the code. So if you have a notebook, okay, in Python you can create a data frame, and when you write the data frame, you have to use the format, okay, df.write.format delta save as table, right? And this is what's going to save your table as a delta table. Now you can, the you have to specify the path where the file is. The If it's local within your OneLake, you can use files, or if it's in a storage account in ADLS, you have to provide the AVFS path. Okay. Now within the delta table, you can also do, like, create a delta table without a file. So this is the delta table dot create syntax that you can use, just like in SQL you just create table without actually loading. So after you create it, you can do insert into, right? So this is kind of equivalent of that in delta. So you inside delta table dot create, within that you do add column and specify the column name and data type for each column, and do execute. And when you run this, you create your delta table. Okay. Or you can use SQL, right? In Spark you can use Python, or you can use the Spark SQL. So in SQL you say create table name, and give it the column name, and say it's not null or data type, right? And the keyword here is using delta. As long as you are using the keyword using delta, this table will be created as a delta table. Instead of the schema, you can also, like, if you want to create a delta table out of a file and you want to kind of infer the schema from the file, the syntax is create table, table name, using delta, and location. So in the location, you specify your CSV file or whatever flat file you have, and it would read it and it would create your table using the schema that's there in the file. Once you load your delta file, you can always use df.write format delta.save and the path of the delta file. Okay, when you save, you have the option of either save with overwrite, or you can write with append. So append would just add to the existing data, overwrite would overwrite the data, right? um, Instead of that SQL syntax, you can just use the spark.sql command to run your SQL query, and you can do insert into to add data to your delta table, right? You can run a simple select statement as spark SQL. You can update your delta table and set values just like you do in SQL. So, because of the transaction log, delta tables now support update, okay, both insert and update. And you can use, select star to select, and you can limit the number of records you want to see, right? You can, create conditions, right? So for example, within delta table, you can say delta table dot update, I want to set this price with the condition that the category is accessory. So you can conditionally update something. This is the kind of equivalent in a SQL table saying update this where this column is this, right? It's kind of equivalent of that in a delta table scenario, and the syntax here is delta table dot update. Okay. Anytime you want to see the history of the changes that has happened, you can say describe history and the delta table name, and it will give you the history that, okay, the create table happened, then some insert happened, and then an update happened. So all that history is maintained in delta log, and you can see it by using the command describe history. Since it's maintaining the history, you can go back in time. You can say read the delta table with option. Okay, you can read delta table with a specific version number or a timestamp of a particular time. You can also create delta table from stream. We will see the real-time analytics, how to handle streams later, but spark.read stream allows you to uh, read a streaming data, and you can set the format to delta right there. So while you're reading a streaming data, you read it into a delta table, right? And you can also create a schema in struct. So while you are reading, you read stream with that schema, so it's a schema on read. So you're kind of enforcing at the time of read that read with this schema. Okay. So for a, particular table, you can using SQL syntax, you can do the same, saying create table using delta with location, no, this file, and then you can do select the column names that you want to select, and finally you stop the stream using delta stream dot stop. So your stream starts when you do read stream, your stream stops when you do that in the read stream, whatever variable you read it into. Okay, you say stream dot stop, that's when it stops. Okay, now that kind of covers delta table. So the lake house, you might be hearing, lake house architecture. You might hear something called as medallion architecture, right? So a lake house is nothing but your delta lake, where the data is stored in delta format. Okay, so that's what's called a lake house architecture. That's the fundamental of it. The a medallion architecture has the same lake house spread into bronze, silver, and gold. So bronze, silver, or gold, they are all again lake house. You can have those lake house in same workspace or different workspace. It kind of depends on a lot of business needs, different factors to be considered. But the idea is that your bronze lake house is your raw data, your silver lake house is your cleansed data with minor joins, right? So you kind of have the data in a format where then you are ready to go to the next level, where gold, at gold you do the data aggregation and create the final model that you want to use for your BI reporting. So that's no, bronze, silver, gold lake house is what's generally called as medallion architecture. So I showed you how to create a lake house from the data with the load to table feature here, as well as the notebook interface. What I wanted to show you also is that when you create a lakehouse, you also get what's called a SQL Analytics endpoint, right? Once you select that SQL Analytics endpoint, you get this SQL editor interface into your lakehouse, where you can query your delta tables like they are SQL tables. Okay. And you have a visual query interface. So if you don't want to type the SQL query, you can create a visual interface. This is for those citizen developer. If you want like to work with UI instead of code, you just drag and drop your table, and then you can select specific columns. For example, I can choose, let's say instead of all, I select order number or line number, and that's going to change my query to select only two, right? I can also add a group by, so I can group by the sales order number. I can do a count, new column name, let's say line items. I can say count distinct values from sales order line number. Okay, so I can add a group by here without writing SQL syntax. I can just select it here. Now, once I do that, I have, it updated my query. I can then add a report to it. So I can just say visualize the result, so it will build that visual. So now I'm in Power BI. So in my visual query, I have the sales order number and line items, and I can add those to create the visual, right? And I can, instead of the chart, I can do a clustered bar chart, and it changes the visual. So you can directly go from your visual query to Power BI. This also shows how the integration between your lake house, a delta table, to Power BI. So this is the power of Microsoft Fabric with seamless integration, that you can go from a flat file to creating visual all in one. We talked about the lake house. Okay? The lake house compute works on Spark. Okay, so let's now talk a little bit more about Spark. Okay, um, I'm in the data engineering persona. Okay, so you can see there is something called as environment. So this environment refers to your environment name. Okay, so if you're familiar with conda in Python, so you have environment. So in your environment you basically get to select your compute. Okay, so you have, like, you can select like what type of Spark driver you want to use, driver memory. So you have a few parameters that you can change here, and you can change some of the Spark properties. Okay, you can add a YML file and change some of the properties that you might be doing when you do your local Spark development. You can add libraries here. You can, if you have any custom libraries, you can upload. So you might be, in your on-prem environment, you might be creating environment where you have your own custom libraries. You are using a specific version of Python, you're using specific version of Scala, specific version of Python, Spark, right? So all those things you can set here. So when you run your Spark, you can select your environment so that it knows about your library and it knows about your specific version limitations. Okay, now besides that, there is also a Spark job definition. Okay, so in Spark job is typically what you use to schedule a Spark run, right? So you have something like, it requires a Spark code. So you have to give it your Spark file. So it could be a notebook or any Spark code that you have written. You have to enter the code. You have to add your Lakehouse reference, and then you have to run. So this is kind of like the data pipeline equivalent for your Spark, right? So you are running your Spark job with, the specifying the code and some references. Again, I won't go into the details of this, but I just want to show you that Lakehouse works on Spark. So you have these options. Okay, now in terms of writing code, when I talked about Lakehouse, we talked mostly about Delta and we saw the SQL interface. Now, let's say you don't want SQL, you want to do everything in Python, you can do that. So you can create, your data type instruct as a Python. You can read a CSV file and create your data frame, and you can do entire data manipulation within Python data frame ever going to SQL, right? So you can, within data frame, you can select specific columns in a certain way. So within my DF, I'm now saying I will select only customer name and email. So I'm creating new data frame called customer that has only those column. Within those columns, I can, filter out using specific query. Now I'm saying, if item is this, then select those, and now I create another data frame for that. Within that data frame, I can now select specific things, and I can do group by, right? So these are all doing it using Python instead of SQL, right? You can change a column name by giving it an alias. You can do group by, count, order by, right? You can add modify a column. You can do a transformation, right? Finally you can write it back as a delta table. So this is just to show you that if you are used to working with, a Python data frame environment, and you don't necessarily work on SQL, Spark supports both. So you could do everything the Python way or the SQL way, whichever way you prefer. Talked about Lakehouse. Now let's look at warehouse. So I am in my data warehouse persona here. Now you can select, warehouse and create a new warehouse, right? You give it a name. Uh, I have create a data warehouse here. So when you create the data warehouse, it had these different views. You can go into the data mode, to see different data. For like, if you hover over a column name, it would show the data. You can go to the query view to look at your SQL query. You can go to the model view to see the model. So first I'm going to show you the query, because I use this query to create this warehouse. So I'm saying, if there's this table, to drop it and then create dim product, saying, giving it the column names and data types, and I'm inserting a bunch of records to it, right? So a simple SQL create statement and insert statement, right? Similarly, create div date and insert into that. So this is a long query. All it does is just bunch of create table statements and insert table statements. Similarly, fact, sales order. Okay. Now in the model view, you can see all the tables that are created. Typically, in a warehouse scenario, we use what's called a star schema. So a star schema has what's called a dimension table and fact table, right? So your dimension table, so anything like, convention here is that anything with the keyword dim is a dimension table. Anything with the keyword fact is a fact table, right? So my customer is a dimension table, my date is a dimension table, my product is a dimension table, right? So a way to know, a good rule of thumb is any table name that's a noun, so it's something that represents one of your entity. It's a description of that. So that's what you enter as a dimension table. Anything about what that entity is doing. For example, sales order. So my customer ordered something. So anything that's an action related, where you are recording the action made by that entity, that action data you want to enter as a fact. So it's a fact that this customer did this, so that's a fact, right? So that's kind of a way to remember. So this is, in the schema view, you can do referential integrity, because SQL warehouse is like is the analytical version of SQL. So this is pure SQL. You can have referential integrity here. So you can, for example, I added a relationship here. So my fact sales order and dim product, there is a many to one relationship. So one product might have been ordered multiple times. So there would be multiple records in fact sales order related to the primary key of dim product, right? So there is a many to one relationship. So that relationship is shown here. Okay. Now you can have, so you can do that to create tables. I have also created views, so you can, say create a view to create the view, right? So notice here, I have some create view query here. So that created, you can have functions, you can have stored procedures, you can, have SQL users and assign roles. Very typical of any SQL server data, right? And I want to show you here that you do have like visual query, like I showed you in the delta table, how we created visual query. You have similar visual query created here. So for example, I added my dim product and fact sales order, and then I added a reference between them, and I added, like, for the fact sales order, I merged the query. Okay. So I did a merge, and then I then expanded the product name. So I created a product name column out of this. So uh, you can see all the changes that happened here, right? So you can view the SQL code for this, right? And just like last time, you can again visualize the result of whatever query result happened because of the visual query. into a data. For example, if I want to see product and quantity, so I want to a report of what product was ordered, and I want that as a clustered bar chart like last time. I can have that just like last time, all the products with a bar chart of how many were ordered, right? So you can do your BI reporting right off of your warehouse. Let's now look at the data science part of Microsoft Fabric. So I am in the data science view here. So with data science, you have a few items like ML model. Okay, so you can save your machine learning model in Microsoft Fabric. There is something called as experiment. Okay, so each model training run is called an experiment, right? So experiment is kind of equivalent of pipeline or Spark job for machine learning, right? And of course, you write code in Notebook. Okay, so let's look at a Notebook code for machine learning. Okay, so I'm taking a Parquet file from a storage account. So I loaded it into a data frame. It's a diabetes data, so it has like age, sex, BMI, some of those information. I can see the first few data, right? So I can clean do minor data transformation. So anything above, or 211.5, I consider risk. So the Y field is what I'm trying to predict, right? So, I can make it a regression where I'm just trying to predict this number, or I can set a threshold like, 211.5, and I can just say whether it's risky or not. So I can, if the output is binary, then I can turn it into a classification problem, right? So I created a new field called risk. So it's risk is 0 or 1. It's 0 if it's less than 211.5, if it's 1 if it's greater than 211.5. So my risk field is what I'm going to predict for my classification problem, and Y field is what I'm going to predict for my regression problem. Now, so I use the test and split in sklearn to split the data into training and testing. I'm using the ML Flow library. ML Flow is an open source machine learning library that you can use to manage the life cycle of your machine learning. So here I am creating an experiment. So for doing my ML training, I'm creating an experiment called diabetes regression, and using that I use the ML Flow auto log, so all my logs will be captured. I'm using linear regression to create a model. So that experiment is going to create my linear regression model. Again, I am going to test transplant and create a classification model where I'm now trying to predict the risk part of it, right? So the risk is in my Y. So risk is what I'm trying to predict. Again, I use ML Flow. I log everything using Autolog. And when I run it, I get this experiment named diabetes classification. So let's look at what a machine learning experiment looks like. Okay, so within the experiment you get basic information like some of the metrics. Okay, what's the accuracy score, what's the F1 score, since it's a classification problem. All the metrics are classification related. Some of the run parameters are here, and you can save it as an ML model. So if I click save, I can save this model as a new ML model within my Microsoft Fabric. Okay, and once I save this model, I think I have some of those models saved. Let's look at some of those. Model. I wanted to show you what a model looks like. So here is that diabetes classification model that I saved. Now, when you view that model, you see, you can download this model. So if you want to have it in your machine and you want to deploy it into AKS, you can download this model. You get a wizard where you can apply this model, with an input output to get prediction. So typically you can just do that in a notebook, but if you want to, you can take advantage of this wizard to get your prediction out of that ML model. Let's now look at the real-time analytics in Microsoft Fabric. So I'm in the real-time analytics view in Microsoft Fabric. So some of the items that you have in real-time analytics is KQL database. So the real-time analytics in Microsoft Fabric is built on the Gusto query language, or that's what KQL stands for. And so the KQL database is how the data gets stored uh, in real-time analytics. This Gusto query language database, it allows you very fast retrieval of data, so it's very ideal for real-time analytics. And any query that you do on the data gets saved as a KQL query set. You can use event stream. For example, if I create an event stream, um, okay, so if I create this event stream, the event stream allows you to uh, select a source. Okay, typically you could use event hub as a source. For example, in the source I can have a sample data, I can use Azure Event Hub, I can use IoT Hub. These are typical sources of streaming data. So I can so they would come to my Synapse real-time analytics, and then I get to save them into Lakehouse or a KQL database, and I can have reflex. We'll talk about data activator later, but I can have a reflex to kind of take action on it, right? So I have already created a KQL database. If you look at within the real-time analytics, uh, if you create a KQL database, let's say create a KQL database, you have several ways to get data into it. And you can take data from OneLake, you can use Event Hub, you can take from Azure Storage. You do have the option of uploading a local file. You can have pipelines, you can have a local file to add data to it. So that's exactly what I have done here. So I've created used my sales data to add to this KQL database. And using that sales data, I have created this table. Notice it also has option for shortcut, just like in the Lakehouse. You have materialized views. So if you created a view, you can save it here. Okay. So if you go to the query table, say so any 100 record, so that kind of gives you an example of what Kusto query looks like. So it's a little bit different from sales. So it uses this pipe syntax. So sales is my table name. When I give the name sales, if I remove this, that's going to give me, that's kind of equivalent to the select star from sales, right? So if I just say sales and run it, it's going to show me all the record. If I say take 100, it's going to randomly take 100 records out of that and show it to me. You also have, like, for example, in sales, I can also say where order date between this. So this is how you do where query. So every thing that you do on top of the table is done through this pipe operator. So I use pipe, then add a where operator. I do pipe, then do summarize. So summarize is kind of the aggregate. So I do total revenue with sum of unit price by item. So that's how I kind of do. It's kind of equivalent to saying group by item and sum the unit price, and that's what I'm using to create this new column. I can also do sort by item ascending, and everything is done through this pipe operator. Okay. And simple things like, you can do multiple where sales, so where item is this, and you can do date time is this, and and you can run this, and uh, you know uh, the result that you get, again, you can use Power BI report straight out of this also, just like you created from Lakehouse as well as data warehouse. For our final module, we'll look at data activator. So I am in my data activator persona. Data activator has this main component called reflex. So if you click reflex, you can create reflex using your own data or sample data, right? So there is some sample data already there in Microsoft Fabric. If you choose your own data, you have to select a Power BI, a particular report, a query to kind of select the data out of it. I'm going to use the simulator, so I already have the sample data loaded here. So when you load the sample data, you get something like this. Okay, so you have a design view, where a lot of the triggers are already created. Okay, you can see here. And if you go to data mode, you can see you can see the data for let's say, in this case, there is a package that's in transit, and there's some medicine in it. So let's say I want to in the data mode, you can assign this to new object. Let's say I call it random packages, and I select the package ID, the properties I want to select, maybe city, cold chain, temperature, and special care, right? And I can save and go to design mode, right? So when I do that, I get the event, and for this event, I can create a new trigger. Okay. So for the trigger, so when you have a trigger, there are three things here. For first you want to detect, then you want to act. Okay, so first you want to select what you are trying to check, right? So I'm interested in temperature because I want to check if the temperature is high, then I want to do something. So you select a temperature, then you want to detect. Okay, so temperature is a numeric field. Okay, so maybe I want to detect an exit range, right? So range may be, say, minimum 41 to maybe 100, right? So for this temperature range, I can add a filter and say city equal Seattle, right? So I can keep adding more filter. So maybe something like that. Let's leave this for now. So once you are detect, so finally after you have detected, you can create an action, which is a Teams message or a email. So if I select email, it knows my email already since I'm logged in, and I can change this headline here. It's giving me a suggestion in the message. I can say, I can give an additional context, and in additional information, I can select some of these fields to get exact data for everything when this was created, and then I can save this as a trigger, and then I can run it, and every time I get data where this temperature range is met, I would basically get an email.